Welcome back to another LeetCode video. This is going to be my 201st problem solved. 62 unique paths. This is basically a little bit like the last one. So let's go ahead and read it. There is a robot on a m by n grid. The robot is initially located at the top left corner. The robot tries to move to the bottom right corner. The robot can only move either down or right at any point. Given the two integers m and n, return the number of possible unique paths that the robot can take to reach the bottom right corner. And yeah, whatever, this doesn't matter. So what we're gonna do is we're gonna try to go down as long as we can, and then we'll go right as long as we can. And our base case will be when we hit this, and then we're gonna use like some recursion to like do all of this, and then basically use every path, and then this this will probably be time limit exceeded, so we're just gonna add some caching after, right? So for now we'll just do the regular solution. So we'll have a variable count, which will just be the number of unique paths, and then we'll make our dynamic programming function. We'll send in row and column, and then so we're just gonna do the non-local. Right, so this is just gonna ensure that this is in the same this function can change count and see count. So our base case would be if row equals m minus 1, right? Because this is gonna be for the problem, yeah, you see, it's gonna be minus 1 because the problem explanation basically says that this is 1 1 in terms of m and n, but it's actually that. And the column is at n minus 1. Then we do count plus equal 1 return, right? And then our recursive case will be if we can go down first or right first, it really doesn't matter. We'll go down first if row plus 1 is less than what's it, m? Yep. And then we'll just call it, so dp row plus 1 column. And then if now we'll go right if column plus 1 is less than n, dp row, and then we'll change the column to plus 1, right? And then we're basically done this, and then so we would just call this function starting at 0 0, and then we would return count. So let's go ahead and run this. Okay, yeah, so this works. Let's see, our time limit exceeded. Yeah, so that basically just means this is taking too long to solve, for example, for this case. So we would have to cache this somehow, right? So how we're going to cache this is going to use a DP array, dynamic program array. And basically this is going to be like, for each point at the grid, once we've done this, we're going to store it. Once we've done all of this, we're going to store it at this row and column. So if we were to visit that before or visit it again, we don't have to do all this recursive computation again, right? And so here, instead of up and count, we will just return 1, and it'll make sense in a bit. Pretty sure this like tail recursion, head recursion, some type of recursion. I'm pretty sure it might be tail recursion. Yeah. So yeah, let's just run this to be. So we're gonna call paths or path, and then how we're gonna add is gonna be path plus equal this, right? And path plus equal this, right? So it's just going to be the chaining of ones added to the path. And then here we're actually going to return path for now. So now let's make our dynamic, our cache, right? So you have to do it for this whole like m by n thing, right? So let's make an m by n grid. So we'll do none for in range n. So that's just gonna make it all none for all the rows. And then now let's do the columns. So for in range m. So now just to implement the recursion, so we would do cache at the row and the column. So this row and this column will have this many paths. And then now we will say if cache at this row and this column. So if we computed this properly previously and it's not none, we would return this cache. There's a term for this. This is called memoization, where you store previously computed stuff that you've previously computed, so you don't have to do the extra work again. Let's see if this runs. Oh, I did row and column. Oh yeah, we'll get rid of that, but I did row and column instead of 0 and 0, and non-local count is gone. Let's go. Okay, that looks good. Submit. And there we have it. It's pretty fast. Let's see what these people did. Oh, they just done it iteratively. Yeah, I guess that's possible as well. Okay, yeah. Iteratively is probably faster, but recursively it just like it's just better in my opinion. It's better to like explain if or what is how does this work? Oh yeah. Yeah, I get it. So they just did like what's it, bottom up or something? Yeah. Yeah, so they started initially from that corner. Alright, anyways, make sure to like and subscribe. Come back for another video tomorrow. I'm not gonna post anymore today.